Welcome to qnawire.
Welcome to the problem number 22.48. This is chapter 22, Gauss law. So we are given that there is a solid conductor sphere having radius r and carries positively charged q. This sphere is surrounded by insulating shell which has inner radius r and outer radius capital 2R. That means there is this sphere is on that sphere, and this is a conducting sphere. And we know that whatever the charge on the conducting sphere moves towards the surface or on the surface. So this Q also moves on the inner surface of the shell. And this insulating material, so this is an insulating material. So this has rho uniform charge density, and we are given that the total Q is 0. So we need to find out the rho. Total Q equals to 0. And we have another B and C part of this question. We will go one by one. So let's find out the answer of the part A. So we have total Q equals to 0. So that means whatever the rho times dV charge is contained within this volume equals to minus Q. Because if this is Q, so this should be a minus Q. So Q on insulating material should be equals to minus Q, so the total charge could be 0. So now talking about this volume, so this is sphere. Now this is bounded by inner sphere and outer sphere. So we are finding out volume of this shell. So this would be 4 by 3 pi 2r cube, volume of the outer shell minus volume of the inner shell, which gives you the volume of this hollow shell. So this should be minus q, and this comes out to be rho equals to minus 3q over 28 pi r cube. So this is your answer for part A. So the total charge on this whole system is 0. So rho should be this much. Now going to the B part. So we are the B part. Since so we need to find out the electric field between all regions. So let's find out the electric field between this region, between this small space. So there is no charge contained because whatever the charge was there on this solid sphere, this is a conducting material. So all the charge moves onto the surface of this conducting material, and this surface conducting material is the inner surface of the outer shell. So that means we have E equals to 0 inside conducting material. Now going for the R greater than 2R. Similarly, the total charge contained for this, if you take some point and apply the Gauss law, so let's apply the Gauss law if you want to see the exact calculation. So this would be phi, or you just apply E dot ds equals to total enclosed over epsilon. The total charge on this sphere is 0, so we have 0. So therefore electric field is 0. Now talking about within the R and capital 2R. So we go to the another slide. So we have R less than capital 2R and greater than R or capital R. So we have minus Q on this one Q, but this minus Q is distributed over the whole volume. So first we assume a sphere. So let's assume a sphere having Gaussian surface having radius r. So we need to find out the charge here. So E dot ds integral equals to q enclosed over epsilon naught. Now q enclosed, this one q, and this the volume contained within this sphere or spherical hollow sphere. So we have q plus rho dv starting from r to r over epsilon naught. So this comes out to be q over epsilon naught plus rho 4 by 3 pi r cube minus r cube. So E dot ds, now looking at this one, so the electric field is symmetric, so we take out the area of the sphere. So this is 4 pi r square. So electric field would be q plus rho times 4 by 3 pi r cube minus r cube over 4 pi r square epsilon naught. So this is the electric field between region capital R and 2r. Now substituting the value the rho naught or rho, so we have equals to 2 by 7 q over pi epsilon naught r square minus capital Q r over 28 pi epsilon naught r cube. So just put the value the rho. So that's your answer for your part A and B. Now we go to the part C. So we need to find out the or plot the graph between E and R. So we have this plot. So this is our electric field and this is our R. So looking at this one, so there is no electric field between R less than A R and R greater than 2R. So electric field starts from this region, which is R equals to capital R, and this region capital R equals to 2R. And looking at this formula here, so this is the electric field and this is dependent on 1 over R square and minus some factor times R. So we have this graph as follows. We start from some value and it goes there. So this is a graph or the sketch. So that's your answer for this question. Thank you for watching the video.